Hey guys, so in today's lecture, we are going to discuss various energy audit instruments and metering, and also we are going to discuss plant energy performance. So, so first we will discuss plant energy performance. So, last time I have given an equation of production factor. So, production factor production factor is equal to current year's production divided by reference year's production. So that is the production factor. So if the production factor is X, then energy consumption would have been increased by X time. The any energy savings has not been successfully implemented. Sometimes the energy consumption may increase than production factor due to some reasons. So another factor which is considered for performing energy performance is RYE, reference year equivalent energy usage. So RYE is the energy that would have been used to produce the current year's production. So RYE, reference year energy, RYE will be equal to reference year energy use into production factor. So it is reference year energy use into production factor. So this value is compared with the current year's energy consumption, so that we can calculate the plant's energy performance. So basically you have seen that we will reference one of the years energy production, and based on that reference we will find other, so whichever year is the best for using energy, so that will be considered as a reference. And then if you will multiply it with production factor, so how much production has increased, so that much energy should be consumption should be increased. So that is reference year energy factor. Then plant energy performance. Plant energy performance will be plant energy performance will be a reference year energy factor RYE minus current year's consumption divided by reference year equivalent. Reference year's equivalent. So this will be the plant's energy performance. So these are few terms which are used to find out how much energy is consumed. So we have seen plant energy performance, reference year equivalent energy factor, and production factor. So three main we have seen. So now we will see next topic, that is methods to improve energy performance. So what are the methods which we can use to improve the performance? So first is matching of energy usage to requirement. So there is always there will always be a mismatch between users requirement and capacity of the equipment. Due to higher capacity of equipments are run on only part load, so this leads to energy efficiency. So this mismatch will spoil the energy management. So while designing the equipment, some safety margins are being kept in order to allow users to match the need by using lower rated equipments. So for example, adoption of a lighting in place of less effective area. So that is an example for eliminating mismatch of energy usage. Then second example will be that moderating chilled water temperature as per the chilling needs. So these are few examples which we can use in industry. So next is similarly this comes under maximizing system efficiencies. So by this example you can also increase the efficiency of the systems. Then next is optimizing input energy requirement. So how you can optimize the input energy requirements? So energy performance can be improved by how we can maximize the system efficiencies. So by providing proper insulation wherever it is necessary, so heat is not dissipated. So there we can, for furnace or example, for that we can increase the efficiency. Then avoiding the leakages of steam in the boiler, uh, so that we can increase the efficiency. Then adoption of combustion controls for maximum combustion efficiency, so that also we can increase the efficiency of the system. Then replacing the pumps, fans, air compressor or refrigeration system which are old and not efficient. Then periodic maintenance of the various instruments, and also replacing the systems having higher specification. So these all are examples by which we can maximize the system efficiency. Now how we can optimize the input energy requirement? So by using alternate source of energy like renewable energy sources, so we can optimize the input energy requirement. Then reducing the waste heat from the system, so that is another example. And maximizing the waste heat recovery from the system, that water heat is wasted that we can recover. Then use cogeneration plants for power generation, on also reheating or intercooling techniques in power plants. So these all are examples by which you can optimize the input energy requirement. Then last is fuel substitution. So what is fuel substitution? So the replacement of electric heaters by steam heaters. So wherever the heating applications is there, so we should make sure that for heating applications we directly use the steam, or we can directly use the uh, coal or fossil fuel, because after all the electricity is produced from the steam. So the efficiency of converting from steam to electricity and then electricity to steam to heat, so much efficiency is reduced. So using steam heaters instead of electric heaters, so that is one fuel substitution. Then replacement of steam electricity based heating water system with solar based system, so we can also use solar based system for heating. Then use of biofuels in automobiles in place of fossil fuels, so this is also an example. Then use of CNG is more preferred compared to fossil fuels. So CNG is more available and cheaper than the fossil fuel like petrol and diesel. So and these are the steps by which we can increase the performance of the energy plant. So next uh, topic is energy audit instruments and metering. So here energy audit instruments and metering. We have divided all the instruments in two parts, that is electrical systems and mechanical systems. So electrical systems are used to measure the electricity is various parameters such as current, voltage, current, then power in watt, power, then power factor, then frequency, then power consumption, that is kilowatt hour, and maximum demand, that is kilowatt ampere. So this all parameters need to be measured using various instruments. So multimeter is used generally for measuring all the parameters. So this kind of instruments can be used without stopping the machine. So this all are will come under electrical systems. Then mechanical systems. So various parameters such as temperature, then speed, fuel efficiency, emission parameters, for flow parameters, then humidity parameters. So all radiation, so all we will measure with respect to different instruments. So let's start with the first, that is speed measurement. So speed we can measure with the help of two types of measurement device, that is contact and non-contact type. So tachometer is a contact type speed uh, measurement device. So the probe of a tachometer is kept in direct contact with the rotating machine element, and that displays the RPM. So that is one speed measurement device. Then certain internal parts of machine cannot be directly contacted. So for such conditions, stroboscope, that is STROBOSCOPE, stroboscope is used. So it works on the principle of light that at precise frequency. A stroboscope light source provides a high intensity flash. So it provides a high intensity flash of light on the rotating element. So when the light source is made to fall on an object with periodic motion, it appears that motion is slowed down or stopped when both the frequencies bear at a definite relationship. So with the help of this light, when both their frequencies are matched, so resonance is occurred. So at that time we can find that what is the speed of the light, what is the speed of the uh, rotating element. So there are two, we have discussed two measuring devices for speed. One is tachometer, other is stroboscope. Then next is flow measurement. So in flow measurement, stroboscope is a non-contact type measuring device which can also be used. Then ultrasonic flow meter is a non-contact type flow measurement device. And there are two main types of ultrascopic flow meters. So for speed we use in stroboscope, and for flow measurement we will see ultrasonic flow meters. So there are two flow meters. Number one is transit type, and Doppler, and second is Doppler. So in transit type ultrasonic meter, have both sender and receiver. We have both a sender and a receiver. So they send two ultrasonic signals across a pipe. So they pass two ultrasonic signal across a pipe, and one signal is passing with the flow and one in opposite direction of flow. So signal passing with the flow is faster than the signal opposite direction. So two signals we are sending, one in the direction of flow and one in opposite direction. So there are two signals. So one signal will move faster than the uh, opposite direction, and this device measures the time period between these two, and the time difference is proportional to the flow rate. So from with the help of this principle we find the transit ultrasonic meter, flow measurement meter. Then in Doppler, so what is the principle in Doppler? So Doppler ultrasonic flow meters measure dirty liquids. They calculate frequency shift that occurs when ultrasonic signals reflect off particles in the flow stream. So that is the principle of Doppler. So we have seen two, transit and Doppler. Then next is temperature measurement. So temperature measurement is also having two types of measurement, that is contact type and non-contact type. So thermocouple is a contact type measurement device, and this device can only be used where the temperature is less than temperature of metal, which is used for measurement. Then other is non-contact type, so which we have recently seen in COVID, that is infrared thermometers, that is infrared thermometer gun which we have seen. So they measures the thermal radiation emitted from the object. So since the emissivity of the object is fixed, so the temperature of the object can be calculated using infrared energy emitted by the object. So with this help of we can find the temperature. Then next is emission measurement. So what is emission? So uh, the gas emission which is exhausting from the tailpipe of an automobile, so that we have to measure. So fire rate, fuel efficiency monitor and combustion gas analyzer are used for measuring emission measurement. So fire rate, fuel efficiency monitor and combustion gas analyzer. So first we will see fire rate. So fire rate works on Orsted's method of volumetric analysis. So what it does, so it measures fire rate. Fire rate measures oxygen and carbon dioxide on its scale, that how much is O2 and CO2. So in this uh, hand below pump draws flue bases in the solution, that is flue gases as drawn in the solution. So chemical reactions changes the liquid volume, that reveals the amount of gas in percentage. So the reagent used for absorbing CO2, so for absorbing CO2 is potassium hydroxide. Potassium hydroxide, and for absorbing O2, oxygen is chromous chloride. chromous chloride is used. So chemical reactions takes place between these flue gases and absorbents, and volume of gases is available on the scale. So with this help of this uh, with the help of this principle, the oxygen and CO2 is measured. Then fuel efficiency monitor. So in fuel efficiency monitor, so it measures oxygen and temperature of the flue gases. So calorific values of common fuels are fed into microprocessor, which is uh, calculate the combustion efficiency. So it is just a monitor in which you can fed the data with the help of fire rate or any other instruments. Then combustion gas analyzer. So in combustion gas analyzer, so this measures so gas gas analyzer combustion gas analyzer measures CO2, NOx, SOx and CO. So it measures mostly all the pollutants, that is carbon dioxide, carbon monoxide, nitrogen oxides and sulfur oxides. So specific sensors are sealed inside the equipment that can be changed to measure a particular gas. And gas analyzer has two probes connection, so two gases can be measured simultaneously. So this is our combustion gas analyzer. Then next is humidity measurement. So for measuring humidity, a psychrometer is a device which is used to measure humidity. So it has two thermometers, out of which one is simple thermometer and other is lapped with a cloth cover. So the ordinary thermometer measures dBT. So as we know, the ordinary thermometer measures dBT and the other thermometer measures WBT. So a handle is provided to rotate the apparatus and readings are taken for dBT and WBT. Using this temperatures, humidity is calculated. What is dBT and WBT? Then illumination measurement. So illumination measurement in illumination measurement, uh, lux meter lux meter is used for measuring illumination. So a light sensitive cell measures the incident light. So there is a cell which measures the incident light and evaluates that against the human daylight. So the resulting value will be the lux, intensity in lux. So that is illumination measurement. And last but not the least is energy measurement. So a smart meter usually refers to electric meters which keep the detailed statistics of usage. So the primary purpose of our meters is to provide information that high end users use their electricity on a real time basis. So wireless communication is used for communicating data, so time and money are saved. So it provides accurate reading and is controlled by mobile or internet. So that is smart meters for measuring electricity. So this all are the major instruments for metering. So this ends the chapter, and we will see next chapter, that is fourth, energy efficiency in thermal utilities and systems. So thank you very much.